Let's talk about describing data with graphs. So first you have a distribution of a variable. That's what values your variable can take and how often it takes each value. So it's just some way to describe your data. We can show the distribution of categorical variables with bar charts or bar graphs and pie charts. This is just some way to show the categories and the count or percent of the cases that fall into each category. So for example, here's the market shares for major GPS brands sold in the US. I think this is quite outdated, but we have Garmin for 47%. So you'll see here in the bar chart that Garmin went up to 47%. We had TomTom at 19%, so TomTom 19%, etc. In the pie chart, Garmin took up 47% of the area of the circle, TomTom took up 19%. You'll notice in the bar chart that we put them in decreasing order. So for bar charts or bar graphs, put the categories in decreasing order. It makes it easier to see, except for if you ever have a category like other or something that doesn't seem to fit with all your other categories. Sometimes we'll put that at the end to make it more obvious, but otherwise they should be in decreasing order to make it easier to see. Now let's talk about histograms for numerical variables. Histograms aren't the only thing we can do, but it is very common. So let's look at histograms. We divide the data into bins or groups or classes, whatever you want to call it, of equal width. And we display the counts or percentages of the observations that fall into each class. So here's some distribution of IQ scores, and we want to make a histogram for the data. So we have the IQ scores for 60 randomly chosen 5th grade students. So here's all the data, 145, etc. It's going to be easier if you first reorder the test scores. So notice here I put all of the test scores in order, and you pick your classes. There is not a right way to do this, okay? There are some choices that are better than others, but there's not a specific way you know in advance. So I decided to go just like every 5. So my bins go from 80 to 84, 85 to 89, 90 to 94, etc. So I'm just doing 5 for each bin, a width of 5. So let's count everything from 80 to 84. So that would be 81 and 82, so that's 2. 85 to 89 would be 1. 90 to 94 would be 2. 95 to 99 would be 2. And I filled in all the rest for us to save time. Now you should always label your histograms. So here I label IQ scores. And on this side I would put frequency or count if you prefer. That means the same thing. Better move down that IQ score. So I have room to label this. So let's see. We're going to start at 80, 85, 90, 95, 100. So you can see I labeled everything by 5. And up this side, I'm going to do my count. Let's just count by 1. So 1, 2, 3, 4. Let's skip a few. 6, 8, 10, 12. Okay, I won't skip it. Okay, so now that we have everything labeled, we come over here. So from 80 to 84, 85, we have 2. Then from 85 to 89, we have 1. Then 2. Then 2. Then at 100 we have 8, 6, 11, 7, 6, 5, 5, 4, 1, 1. If you shade it in, it just makes it a little bit easier to see on here. So now we can kind of look at it and see something about our data. Like I can see it spread from 80 to 150. Looks like the most common values between 110 and 115. Looks like we have quite a bit between 100 and 140. That kind of seems to be the bulk of our data. You just kind of look at the histogram and quickly kind of get a feel for what numbers are in your data set. Now I want you to try and see what happens if you pick other classes with your IQ scores. So I picked out your bins, so now go back through and try 80 to 99, etc., and see what it looks like. Now I went through the IQ scores and used my computer and used different bin widths. So for a bin width of 2, 7, and 20. Notice when I use a bin width of 2, it makes it kind of hard to really see anything because there's so many spikes. It just doesn't look pleasing to our eyes. A bin width of 7 looks pretty good. I'd be happy with that one. A bin width of 20, I don't really like that either because it doesn't tell me much of anything. There's only 4 bars. So that has too few, that has too many. It just makes it harder to see what's happening in our data. But this bin width of 7, that looks pretty good. You might notice also that this says percent instead of frequency. So sometimes the software, instead of telling you how many of each value, will tell you the percent of each value. And that's just fine. The shape still looks the same.